Should you hydrate? How long should you hydrate? Any recommendations?
So I think one of the challenges that we've seen is people who do IVRT studies and are accustomed or see protocols for wetting the membrane, the filter membrane, maybe utilizing some of those approaches when they're now dealing with skin and they're taking the membrane and submerging it for extended periods of time, mounting it and dosing it. And I think some of the concerns there, I spoke about that a little bit during my talk, that the stratum corneum, as the hydration increases, and this is the problem with occlusion, as you all know as well, that because of the transepidermal water being occluded, that can really overhydrate the stratum corneum and increase permeability. And one of the advantages of the normal skin barrier over, for example, diseased skin, is that it's very discriminating. And so the question becomes, as it becomes more and more permeable, as it deviates more from its natural state, do we have as discriminating a system? And so the recommendation is there are times when you might need to, or you might choose to do, let's say, an electrical barrier integrity test. And so you may end up putting some buffer on top, or you may choose a tritiated water test and you may put some buffer on top. But give that skin time to dry out. And likewise, when the skin is thawed, that skin can be kept in, let's say, a Ziploc bag or something like that, and the warm water that you use to thaw it can just thaw the bag so that it thaws without the skin itself being submerged that period. You can give it a quick rinse. I think quick rinses don't really impact the barrier, but at least that's my thinking about whatever practical measures that can be taken to maintain the skin surface at a dry condition, and to try to keep the underside of the skin moist and at a kind of physiological state of hydration, or not drying out on the bench, or at least equilibrated as soon as you've got it, once you've got it mounted.
Yeah, one thing we actually do in the lab, not so that we're not soaking the stratum corneum, is if we're cutting up the skin to put it into the diffusion cells, we'll actually just float it on a layer of buffer, and then the stratum corneum keeps dry on top, and then you still hydrate the underside with either the receiver fluid or some buffer, for example.
I would say a variety of points were brought up, but it's so key, and I think it was mentioned by a few of the speakers, to record how you're handling the skin and follow that protocol to the T. And the more detail you throw into it, the better. And I know I think, was it Audrey, you mentioned having an observer for the process. I think that's important, but also potentially having a video of your procedure, especially when you're applying the drug to the skin, and that way you can go back and see, oh, I did it that way, maybe, and that I made a slight deviation from how I usually do it. So those approaches could be useful for recording and keeping track of how you handle the skin, and so you can repeat that the next time you do it.
So our practice is typically measure the transepidermal water loss before we load the skin to the diffusion cells, and also after equilibrating the skin for 20 or 30 minutes, and measure it again before we dose the skin. So if we observe any changes in the skin integrity readouts, then we will definitely choose a different piece of skin. And also, like floating, it's especially helpful when we're using just a heat separated epidermis, because it's easier to spread the skin, and then we can cut it into same size pieces for the experiments.
We have some data to demonstrate that TEWL goes down about 10–15% 24 hours after mounting onto a chamber. Now, I don't know how long it actually takes to equilibrate, but at least there's some evidence that there is an equilibration process between mounting of the skin and 24 hours later.